Yes, so I'm going to talk about cracking the chaos ransomware. And this story begins on a dark place on the internet. It's a hacking forum called XSS. And I don't know if anyone speaks Russian here, but it says something like, I developed this new ransomware. I decided to publish it for free. Here you go. It's a builder. So that link is actually gone now, but if you check the web archive, you can see that it looked something like this. So that's the first version. If you look into this ransomware, it's actually not really a ransomware. It's more of a wiperware because it just overwrites every file on the system. It doesn't really encrypt anything, so there's no chance of getting anything back. When we look into the origins of this, we can track that user posting on XSS back to another user, which developed on another forum here that developed a ransomware called Bagley. And that one was also Wiper, by the way. So this is some person that develops this kind of, wipers. It just overwrites pretty much everything and so on. But after that, they actually started developing this wiper. And in version 3, it actually implemented actual encryption, which turns it into a ransomware. The only problem is that every file that is larger than 2 megabytes, it just still wipes. Which means that, it's, you're not going to have that many files that you can get back. So, what happens when someone distributes something like this? We looked into it a bit, and you can see that, it spreads like crazy. And it starts being used all over the place. You don't have to read everything here, it's just to show you how crazy it gets when someone develops something like this. So, just to give you a quick example, instead of going into every detail, this is the Azovstal steel plant in Ukraine, and as part of the kinetic war, this was actually used at the same time that Russia was, making war on Azovstal and Mariupol. They attacked the steel plant with this propaganda message, and on the other side, we have kids that are trolling each other and selling the decryptor via Roblox money. So, that's sort of the full scale of this, right? We have everything from actual war to kids just, playing around. So, this keeps going on, and we have some forks after a while. So you have something called Onyx, and then you have different branches that people call different forks, but it's just really the same name, but they, change the ransomware note and call it something else. So, when this starts to become interesting is when, these, proper ransomware groups actually start using this. So, you have these groups that actually does not just target an individual PC, but they actually break into a company, they escalate to the main admin, they push the ransomware to everywhere, and, do these proper ransomware attacks. And one of the groups that started using this is called VSOP News. That's the same as Onyx, but they rebranded after a while. And you can see that one of the victims is a sheriff's office, for example. Another one is called SolidBit. They also use the same basic ransomware, but their own fork of it. And they also have this, onion site where they publish victims, and you can do trial decrypt to see that it actually works and so on. Another one, which is kind of interesting, is Killnet. So Killnet actually started using this. We haven't really seen any actual successful attack by Killnet, but at least they are claiming that they're using this ransomware. So the picture, keeps growing, and at this point we have VSOP, which is their own branch. We have the Yashma and SolidBit and AstraLocker, and this sort of just keeps growing. And this is where we come into the story, and it was actually a German company that calls us. And I'm gonna do a demo just to kind of show you what their environment looked like. So it's gonna restore this, and when we look at this company, we see that it's the kind of ransomware case that we do investigations of all the time at TrueSec. And it's not like a single PC investigation, but rather it's, they've taken over the entire environment, they created a group policy object and pushed it everywhere, or whatever method they tend to use. So in here I have a few files. You can see this one, for example, my presentation that I'm doing today. just to show you that it's a actual file here. And we have Onyx to XE. And didn't really have that much time to prepare this environment, so let's hope I don't screw up my real computer now. Are you ready? So it starts, I have this annoying Teams notification. It actually keeps running for a while. And aside from that file, I have a few other here as well. It keeps prompting because I'm running it interactively. But we have a few files here. And this just keeps going, trying to iterate every file on the system. When it finds it, it's probably going to encrypt it. It's very slow today. There we go. So files are renamed to .onyx, prompts me with some kind of ransomware note, and it says that all my files are now encrypted by Onyx. Go to this Onion site, enter this blah, blah, blah to log in and chat with us. So you can imagine this company having all systems looking like that. It's not a great situation. So we started looking into this, and we quickly realized that it's chaos. When you just Google for chaos at the time, you can see that the encryption of the files looks something like this. So it has like this tag encrypted key in front, and then it's the encrypted message. But the thing is, when we looked at the files, they didn't look like that at all. So instead, there was like this static salt in the beginning. So it always started with the same sequence. And then it had this other format, and the key was appended to the end of the file. So we figured maybe it's a good idea to look into what else was changed in this ransomware. Because it said online, that it had this like 2 megabyte limit and basically just wipes every file. So we saw that the file size has actually changed, which is, it's not a super great thing because all their big databases and so on will still be wiped. But that important file share that has a lot of PDFs and Excel documents and whatever, we can actually maybe do something with that. So we keep looking into this, and we see that there's a create password function that creates the password. So it's a unique password for every file. It uses that password to use AES, and then it encrypts with a public key. So you have RSA and AES, and it seems very solid, right? Probably nothing we can do. But let's look at that key generation function again. It says random, generate a random password. Is that random really random? No, it's not. In the official documentation, it actually says that you should not use this for the purpose that they're actually using it for. So that's interesting. I don't know that much about cryptography, so I call Carl, which is my awesome colleague, and I ask him, is that system random thing actually just, can I use that, or is it just theoretical? And he says that, yeah, I already got a POC on YouTube. It's very basic. Or not YouTube, but GitHub. So how would this work? When we have this random function, they basically use you give it a seed, and then it gives you something random. So if you change the seed, you get something completely different. Same thing, you keep changing it, and you just get different output. If you give it the same input 2 times, you're going to get the same output. So it's mapped to that seed. If you give it a negative number, it's also going to give you the same. So it's the absolute value of the seed that we're going to get. So what is that seed? It's a 32-bit integer, and in an integer you can only have 2 billion possible seeds. So that's kind of interesting, right? The random password can probably only be 2 billion different passwords. That's not that much. So we look also into the details what they're doing here. They derive the key from that random sequence, that random password, but they only use 1 iteration, which is really, really weak. And they also use a mode called CFB, which is kind of an interesting choice. So we can actually look at, if you take the seed, you generate the random password, you derive the key, then it does that block cipher thingy, and then finally it XORs the plaintext with the encrypted IV, which is basically the first steps, right? And that's sort of the way this CFB thing works. The thing is that we actually know the plaintext, right? We don't know the full plaintext because then we don't need to decrypt anything, but at least we know the start of pretty much every file, because every file has these magic bytes in the beginning, at least most well-known file types. So we can actually do that last step back, and we can get back the encrypted IV. With that known, we just need to sort of create a table, right? So if we take every possible seed, 2 billion possible seeds, and then we get the encrypted IV for the first 4 bytes, then we have a table of every possible password. And we don't really need to care about the RSA part. We just crack the AS part. And that file is just 8 gigs. It's not that big, right? So it's going to be pretty fast to iterate that 8 gigabyte file. So let's implement a decryptor. We go through the steps. So we read the first 4 bytes. Then, based on the file extension, we look up the plain text, which is just, a guess, but it's probably going to be correct. Then we calculate the encrypted IV based on the table. And then we look up the seed by comparing it, in that big table that we have. And then basically we calculate the params from the seed. So it's a pretty straightforward way. And this worked. So we managed to decrypt, 10,000s of files for the customer. So they were pretty happy about that. And we have cracked the Onyx/VSOP ransomware at this point. But then we thought that, since this is this, big thing that they have forked and so on, that maybe we can actually crack the entire ransomware family. And we started looking into how the others looked. And we see that there are some things that are changed when it comes to Onyx. For example, it's thousands of iterations of the key derivation function. And they also use CBC, which means that we can't use that plain text attack trick that we used before. So that kind of sucks. But on the other hand, we can maybe do something else because it's still limited to 2 billion possible passwords. That's still the limitation. So even if we can't be smart and just use the plain text, we can still create a table which contains all those possible encrypted IVs. Problem is that file is going to be 103 gigs. I mean, it's not horrible if you're going to restore your entire company. So you might take the time to download that. But the bigger problem is when I tried to generate this on my computer, it took I calculated something like 200 days. But my friend Carl, he actually knows CUDA. So if you implement this on GPU, it just takes like a minute. And the bottleneck is sort of the SSD not being able to write it faster. So with that said, we have actually decrypted then the main branch of the Chaos ransomware as well. And we still have the other ones, right? We are not really happy yet. We still have Solidbit and so on. So that one is a bit also changed. So it takes the seed, generates an IV, but that is also does another system random and generates the key. So those are like 2 different randoms. And it's not that good because, then you have like all those 2 billion, but for all those, everyone, you still have 2 billion. So it becomes like much, much bigger. So we really need to figure out like what is the seed really? And see if I have probably encrypted my demo now. I didn't really think that through. All right. Let's skip with that. We can start with Snapshot, but that's going to ruin my second demo. All right. So what is the seed? The seed is actually the system time, like the milliseconds since the system booted. Okay. So the number of milliseconds, guess if the first IV that they're generating and the key that they're generating, guess how many times out of 100 that's going to be the same value. Because they're the same amount of times as the system booted, right? Which means that the seed and the IV is still the same, even if you do it in 2 different instances. So this doesn't really change anything for us. So we still have just that same thing, so we can still crack this the same way that we did before. And if it's not the same, then it's just going to be the next millisecond. So it's going to be super trivial to get it. And if someone is actually following what I'm saying here, you might suggest that, but don't you see the last write time of the file? and then you have the time the system was booted in the event log or something. So you could actually just sort of get when this was encrypted. That should be that kind of milliseconds, and then you know the seed. And it's actually true. That would actually work, but the problem is like when we wanted to write this in a like very generic way, then you maybe try to decrypt files from multiple different systems at the same time, and maybe that's there's a lot of different things when you do this in a really big, complex environment. So we wanted to write a like generic method. But if you don't want to wait, you can definitely change that and do it that way. And I mean, it's sort of, if you're cracking something else which has the same vulnerability, then that's something you can definitely make use of. So let's get our files back, including my demo. So I was actually being smart with this demo because it has an explicit like list of files that it's going to encrypt, and 7 said __ is not one of them. So this file is still valid. So let's see. We have these set up. So we have this decryptor that is, you follow this guide, you should accept, and you should also read the documentation. One reason for actually doing that is that this, like some branches of this ransomware creates persistence, which means that if you decrypt the ransomware, that it's just going to keep encrypting. But the fun part is that persistence is actually also decrypted because it's written before the encryption, which means that persistence will only start working if you decrypt your files, which means that you actually need to remove that unless you want to, get encrypted again. So yeah, read the documentation if you're unlucky enough and having to use this. So we specify the file extension. We set the decryptor to Onyx. We select the database file, which I have here. And then we add the folder that we want to decrypt. And I'm just going to pick the desktop. You can always do this for your whole full system, but it's a bit slow to iterate everything. So, and yeah, there we go. So it has decrypted most of the files. The other ones are probably encrypted at some other point, which means that they are slower in time. And we have this presentation again. And it's back. And then I can maybe, it's keep encrypting that one. So let's see. Yeah. So let's continue from the decrypted presentation. So we have decrypted pretty much the entire family at this point, right? So we have the VSOP one, which we used in that company that we helped out. Then you have the main branch, which is the Chaos Builder one that was used by Killnet and so on. The limitation with that one is that still has that 2 megabyte limit. So it's kind of a wiper, but all files below that you can decrypt it, but most of it's going to be destroyed. The thing is though that it actually doesn't properly overwrite the file. So if you don't make any, it just deletes the file, which means that you can actually carve out important files. It's going to be a mess to do that in a big environment, but yeah, you can still get your files back that way. And smaller files that are encrypted, you can get back with the decryptor. So yeah, then we have Solidbit. And what do you do when you manage to do this? We actually had a kind of long discussion on how to approach this, because you don't really want to expose to the threat actor that you're able to get their files back after, that the ransomware doesn't work anymore. So we figured, because at the time there was, we saw that there were indications that it was used against Ukraine. So we started with contacting UA CERT, and then we reached out to FIRST and TFC CERT, which are some global CCERT communities, as well as some police agencies, and distributed it in these, trusted channels. But eventually we talked to Europol, and they published it on No More Ransom. So basically you can, if you're a victim of this, or if you know someone's a victim, you can go to this website and you can download the decryptor for free and use it to get your files back. Which I think one of the big reasons also to do that is because a lot of these are also used in like these personal PC kind of attacks. So yeah, it's published there. Go and download it if you need to. And we actually also decided to publish the source. So if you're interested in how this works in detail, or if you crack another ransomware, then you can just fork this. It's like GLP v3 license. So hopefully that can be of use in case you want to write a decryptor, or if you just want to see and look how it works. And with that said, I'm done and open for questions. Thank you very much.
There would be some questions for our speaker.
Thank you very much. My name is Jasmine. I'd like to have a question on the timeline between the company being or encountering this issue and you coming up with a solution. Like approximately how much time did you spend on it?
I think it was something like 1.5 weeks, something like that.
Wow. That's really fast. Thank you very much.
Thank you. Yeah.
Any other questions?
Yeah.
Don't be shy. Raise your hands.
Hi, and thanks again for the great presentation. It was really
Thank you.
Great to hear. Just a question. In the first case, the first ransomware you decrypted, the weak point was, if I understand correctly, that there's only one round of encryption for the IV, or what was the fact that where did they screw up that?
Yeah, well, I mean, the core issue is the weak random, right? So, like, as long as you have that weak password generation, or essentially the key generation, because that should be secret. If you can guess that, then it's going to be trivial to break it in one way or another. But in the first case, they use this CBF mode, which is, CBC is like the encrypting the key with the plain text, and then it's XORing with the IV. But that one is sort of flipped around. So the last step is that it's doing an XOR with the plain text. So if XOR is this math function that you can sort of roll back by doing the same thing again. So that was the trick. And you can, since it's the first block, you can just do that XOR on the first 4 bytes. So yeah, that's pretty much it. Thank you.
So if I understood correctly, you were breaking the individual encryption of each file?
Yeah.
Why was it not possible to decrypt the master key? Did it use a different random function, or? Yeah,
so the master key, so it encrypts the file with a unique AES key. That's the one we can break. And then it encrypts that AES key with a public RSA key. So that's a completely different key that is being used. And that one is generated on the threat actor side before the attack. So when if you pay the ransom, you're going to get some kind of tool with the private RSA key. Because with that key, you can decrypt all the AES keys and then get every file back. So that's sort of how that works.
Would this private key unique to the system, or is actually would be valid across more systems, as far as you know?
I'm sorry, one more time.
Would the private key, so assuming you pay the ransom once, you get a private key.
Yeah.
The scope of this private key is that system only, so the public key is just generated for that system, or?
The RSA key, you mean?
Yeah.
So that one is per victim, so to speak.
Per victim, okay.
No, so they generate that before the attack, and then the public key is embedded into the executable.
Yeah, no, it was fair to ask. I mean, otherwise you would have paid once and decrypted forever.
Yeah.
Yeah, thank you.
Yeah.
Any other questions?
Hey, thanks again for the talk. I just have a question. Are you familiar with the approach that some antiviruses do, like Dr. Web? I don't know if you're familiar with it, where they say that if you are or you have our agent already, then if you got ransomware, we can always give you your files back or decrypt it. Do you know how does this happen? Or
yeah, so the thing is, the way it usually works is that the threat actor escalates to the highest possible privileges in the environment. And I used to ask my customers, can you yourself change antivirus? And the question is, the answer is yes, right? So why wouldn't the threat actor be able to remove and change your antivirus, right? So all these kind of solutions, they only work until the threat actor has escalated to the full privileges. Then they just delete all the backups, they kill all the antivirus, and so on, stop all services that are locking files, etc. And then they push out the ransomware. So the only real way to defend against this is, of course, to stop the attack before it happens. But if you're going to protect against the actual encryption, is to have offline backups that are off-site, off-domain. It should not be in the same Active Directory domain, and pretty much every word with off in front of, to ensure that they're not writable, so you cannot overwrite them.
Do you have a feeling how many people used your tool? Like, do you have random people telling you thanks for the tool, or how prevalent is the ransomware?
I don't think it's not like the biggest ransomware. Definitely not. So it's not like Lockbit or I don't know, Revel is gone now. But that kind of, it's not that kind of big group. So I don't really have that good answer for it. But it would be interesting to know. But we decided not to include any telemetry or anything like that because we want to sort of respect the privacy of those who are infected with this.
I believe there are going to be much more questions to our speaker. Also, feel free to engage with him after his talk. He's going to be around to grab a coffee and discuss this really, really super important topic. So feel free to reach out to him. One big applause to our speaker.
Thank you.